decision-making in the age of AI. And in this session, we will explore AI-driven insights, data-driven culture, and human and AI connection. So please welcome our next incredible speaker is Mr. Nelson Wu, who will share his insight on leveraging AI for a better decision-making. So Nelson Wu is the managing director of Fiat Jet Air Cargo. And Nelson brings extensive experience in logistic and supply chain management across Southeast Asia and Greater China. And he also has a proven track record of revitalizing business operations, focus on innovation, speed, and excellence in business transformation. Nelson Wu is perfectly positioned to provide the actionable insight on decision making in the age of AI. So please give the warmest welcome to Mr. Nelson Wu, and the stage is yours.
Okay. Great. Hi everyone. Hello to Andrew and Dr. Ko. Okay, let me share the slides first. Just give me a second. Sorry, can I share the application on the PowerPoint? Because I realize there's only a sharing of whole screen.
Do you have? No. I don't have this.
I only share the whole screen there. Okay. Okay, never mind. It's okay. Yeah. Just give me a sec. So let me open my PowerPoint. Okay.
I think you just maybe need to open up your PowerPoint first and then put it to full screen, and then you can share the final screen itself.
Yeah. Sure. Just give me a sec. Yeah. Okay, because I'm doing work simultaneously, so I have a lot of screen opening on my computer. So
Yeah,
I'm not
you need to click on your PowerPoint because now we are seeing your desktop.
precisely.
Okay, good. Great. Now can.
Just let me turn off the notification so the emails doesn't pop up, that just give me a sec, please. All right, good morning, everyone. It is an honor to be today among all the brilliant minds. Just a few weeks ago, I was sitting in a fireside talk session led by Dr. Ko, my professor in the MBS IMBA program. It was during that session that I met with Andrew, whose insights on the Gen AI really opened my eyes. So it just showed me how rapidly the world around us is evolving, and Andrew's perspective wasn't just about technology, it's really about the human and business transformation that AI enables. So that conversation actually stays with me, and it is one of the reasons why I'm here today, to explore how AI is transforming my industry, aviation, not just in some distant future, but right now. So I'm very humbled to share this stage with all the esteemed speakers and also learn from all of you in the audience. This is not just about presentation. I hope it's a dialogue about what is possible when human creativity meets the power of AI. So now let's look into how AI is changing the decision-making in aviation, making process faster, smarter, and more sustainable. Before we dive into the cases, let's take a look at the decision-making landscape, and then let's take a step back to think about the challenges of decision-making in the aviation industry. So for every day, the aviation sector processes a staggering amount of data, from passenger demands to weather conditions, maintenance schedules, and global air traffic. Decisions in this field aren't just about complex. They are actually also high stake. You know, we all know the issue happened recently, the tragedy happened recently with Jeju Air. One misstep can result in delay, increased cost, or worse, safety risk. But here is the challenge. Traditional decision-making process are struggle to keep up. The huge volume of data, coupled with the need for real-time responses, demand a level of speed, accuracy that human alone cannot consistently achieve. So this is where we believe that AI step in as a game changer. Imagine a system that doesn't, just process the data, but also recognize the patterns, predict the risk, and even mitigate them before they occur. It is no longer about reacting to problems. It is about anticipating and preventing them. As we look through this presentation, we'll see how AI is not only simplifying decisions, but also enabling us to make better choices in aviation. Right, let me see. Sorry. So under the hood of AI in aviation, what makes it such a powerful tool for decision-making tool? Let me take a look. Okay. At its core, AI revolutionized decision-making through three fundamental pillars. Data integration, the first pillar, and predictive intelligence and adaptive learning. For data integration, imagine an orchestra of information from sensors on the aircraft, real-time weather updates and passenger demand forecasts coming all together in harmony. So AI can synthesize this data in real time, making sure that there's no piece of the puzzle is missing. Then on the predictive intelligence, think of AI, this is the crystal ball, from AI. By analyzing the patterns and probabilities, it models scenarios and assess the risk, enabling decision-making that can be proactive rather than reactive. For example, you can forecast the maintenance issues, which we will showcase in a later case, before they cause us any delay. And the last one is the adaptive learning. This is where the AI truly shines. Over time, it learns from all the decisions made in the past, adjusts to the new context, and continuously refines its performance. It is like having a system that's getting smarter every day, adapting to the complexities of the aviation world. So altogether, these three pillars form the foundation of AI's ability to transform decision-making. They are not just about theoretical concepts. From the case study later on, that we can see that they are being implemented today to solve the real challenges around the world, especially in the aviation industry. So in the next slide, let's see all the case studies. I realize that the time is pretty short, so I will try to cover as many cases as possible. If I cannot, I will send the slides, to Andrew. Andrew can share with all the audience. So let's dive into a real-world example of how AI is transforming the aviation maintenance through the predictive maintenance. Traditionally, aircraft maintenance was very reactive, addressing the issues by only after they occur, leading to unexpected downtime and increased cost, of course, the customer dissatisfaction. So the case study is from Lufthansa Technik. So they are a pioneer in adopting the AI for maintenance optimization. They develop a system which is called condition analytics. A platform utilizes the machine learning algorithm to analyze the vast amount of sensor data from aircraft components. This system predicts precisely when the components should be replaced and also recommends measures to prevent failures before they ever happen. In the past, the huge amount of volume and complexity of data made the real-time analysis very challenging. However, the advancement of AI and machine learning now allow for the processing of the data with unprecedented speed. AI algorithm can detect the subtle patterns and deviations that were previously undetectable because it's just too complex, too much. And that enabling the prediction of potential failures with remarkable accuracy. Lufthansa, for this case, Lufthansa Technik, they collaborate with Microsoft, okay, via with their Azure AI services and cloud infrastructure. And then they implemented over 50 AI-driven use cases aiming at optimizing maintenance operation and reducing the ground time. So I think that the case actually shows that the success, okay, of this case study from Lufthansa also shows that it can be replicated by other companies or in the aviation industry, or even companies outside the aviation industry, by investing in the advanced analytic platforms, implementing systems capable of processing and analyzing the large data sets, and collaborating with the technology partners, leveraging the expertise from tech companies to integrate the AI solutions effectively. And then, of course, most importantly, need to develop the skilled teams, training personnel to work with AI tools and interpret the predictive analytics for informed decision-making. By embracing all those strategies, the aviation industries can move towards a more proactive and efficient maintenance paradigm, reducing the cost in enhancing the safety. So let's look at another area, which is a very interesting case study on how AI is making an impact in the aircraft design decision-making. So this is a case study about NASA's X-57 Maxwell. So this is the NASA's first all-electric X-plane. Why they call it X-plane? Because it's futuristic. It is aiming to demonstrate the potential of electric propulsion in the aviation. This project is not just about replacing fuel with electricity. It's about reimagining the aircraft design to achieve greater efficiency and sustainability. One of the key innovations of X-57, it is the use of distributed electric propulsion, DEP. This involves placing multiple small electric sensor motors along the wing, which allows for a thinner and more aerodynamically efficient design. However, integrating the DEP into the aircraft, it is a very complex challenge. So this is where AI comes to play. NASA employs advanced computational tools to optimize the design and the performance of the X-57. For instance, they use the computational fluid dynamics, CFD simulations to analyze the airflow around the aircraft. Those simulations generate vast amount of data, which AI algorithm then process the data to identify the optimal configuration for performance and efficiency. And moreover, AI also assists in the mission planning tool, which is called MPT. This is developed for the X-57. The tool simulates all the phases of a flight, from taxi, taking off, climb, cruise, and descent, to optimize the energy use and performance. By analyzing the different flight scenarios, AI helps in planning missions that maximize the aircraft capability while ensuring safety and efficiency. The breakthrough that it deployed, that advanced machine learning, high performance computations, etc. So by embracing those strategies, the aviation industry can move towards more innovative and efficient aircraft design, paving a way for a more sustainable future in the air travel. In the next slides, we will go beyond the aircraft design and also maintenance to look into the day-to-day operations of airline, which are vital to the airline success. First one is route planning and optimization. So imagine the complexity of coordinating thousands of flights daily. For Vietjet, we fly about 450 flights each day, and the flights, each and every flights are influenced by variables like weather patterns, air traffic congestions, fuel costs. Traditionally, route planning was a very manual, time-consuming process, often leading to inefficiency and increased operational costs, and of course, delays, and cancellations, dissatisfaction from the passengers, and compensations, etc. So this case study, let's take a look at how United Airlines addressed the challenge by integrating AI into their operational decision-making process. They developed an AI system, which internally is called MARS, M-A-R-S, which integrates the data from diverse sources. For example, like weather systems, crew schedules, real-time flight status to streamline processes. This system enabled dynamic adjustment to the flight paths, optimizing for efficiency and safety. By consolidating information from various sources, this MARS system provides a very comprehensive view of operational factors, affecting the flights. And with the real-time analysis capability, it processes the data in real time, allowing for immediate adjustment to flight routes in response to changing conditions, like weather and others. And it also has the AI also gives equip the system with predictive analysis, utilizing machine learning algorithm. The system forecasts potential disruptions, enabling for proactive measures to mitigate delay. So the impact, of course, it has streamlined the flight operation, reduced the delay, improving on-time performance, and led to significant fuel savings, directly impacting the airline's bottom line. And then by minimizing the disruptions, the airline can also improve on the overall satisfaction of customers. The shift from manual planning to AI-driven optimization represents a significant leap forward in aviation operations. So this case actually demonstrates how embracing technology can lead to substantial improvement in efficiency and service quality by incorporating AI into the daily operational decision making. So as we continue, let's explore how AI is revolutionizing another critical area, which is the aircraft scheduling and rotation. This is another vital kind of critical decision on the day-to-day basis for aviation industry. Similar to the route planning in the past, scheduling of AC rotation and crew rotations it is a painstakingly manual process. Just imagine, the average block hours especially for the low-cost carriers is range from 12 to 14 hours a day. And then some of the flights with short haul flights, 1 hour, 2 hours, they probably have to rotate 6 to 8 times a day. And then in the past, the planners rely on static models, limited optimization capability, and often face very high level of inefficiency. The result was frequently, scheduling conflicts, underutilized crews, and sometimes, overstretched crews may create a fatigue of the crew members. Okay, and also, of course, increase the operational cost and customer dissatisfaction. Let's look at the case study on Delta Airlines, how they address the challenge, to transform the daily operational decision-making on the fleet management. They implement an AI-driven fleet optimization system that uses machine learning and real-time. You see all the things actually repeat the 3 pillars again. You always start from the machine learning and real-time data to make scheduling smarter and faster and even more adaptable. This system predicts the optimum crew assignment by analyzing variables such as crew availability, regulations, flight timings, and for the crew allocation. The system also incorporates up to the minute maintenance data. We talk about the predictive maintenance, collecting all the data from the sensors in real time. And those data are all integrated as an integral part to support all the decision making in various aspects we will see in all the cases. So those data will be actually to ensure the aircraft, to predict the aircraft availability, when it's needed. So unlike the static schedule in the past, the Delta system with the support from AI, it can dynamically adjust the allocation of the crew members and also the AC rotation in responses to disruption like weather delay, technical issues of the aircraft, or other unforeseen events. And then the result speaks itself. Crew utilization improved by 22%, scheduling conflicts reduced by 35%, significantly enhancing operational stability. Operation costs dropped by 65 million for this case study. And the key breakthrough here is the shift from reactive to proactive scheduling. In the past, disruptions would cause a domino effect. This is the nightmare in the aviation industry, like what I shared just previously. The low-cost carriers can turn around the aircraft 6 to 8 times a day. So one interruption, one delay, it will definitely create a domino effect of delay and inefficiency. But today, AI anticipates those challenges and adjusts the schedule in real time, ensuring seamless operation. So Delta's case is a testament to how AI can turn a traditional rigid system into one that is flexible, efficient, and cost-effective. It's not just about saving money. It is about improving reliability and creating a better experience for passengers and employees. So let's look another, very important decision making for the airline's daily operation, which is passenger demand forecasting. Accurately forecasting passenger directly, this demand accuracy directly influence the decisions on the flight scheduling, pricing strategies, resource allocations, which we talk about the crew members and AC allocation and such. The traditional methods often rely on historical data, statistical models, which while they are useful, they have been useful in the past many years, but it could not fully capture the dynamic nature of the air travel demand. So this case study for American airline, they use a predictive demand intelligence. The project is actually in collaboration with the researchers. They actually use the deep learning model designed to predict the flight level passenger traffic with high accuracy. So basically, the model the model actually ingest a rich data set encompassing the historical traffic figures, fare closure information, seasonalities, etc. Which attributes specific to each flight. The holistic approach allows the system to understand and anticipate the complex demand patterns. Some of the algorithm they use is, like recurrent neural network RNN and, convolutional neural network CAN. The model actually effectively capture both temporal and sequences and also a spatial relationship between the data. And then the integration enables the system to learn the intricate patterns associated with passenger booking for more accurate forecasting. And he also developed some other innovative technology like constructing the 3D tensors, to represent the data, applying the masking strategies to reflect the real world dynamics, and utilizing data augmentation to enhance the diversity and robustness of the training set. In short, it has sophisticated data processing capabilities, which is empowered by the Gen AI. So this model actually demonstrated impressively 33% improvement in the mean square error MSE compared to the traditional forecasting method, leading to a more reliable demand prediction. And with precise demand forecast, American Airlines can optimize the flight schedules, adjust the pricing strategies proactively, and allocate resources more effectively. Ultimately, it enhances the operational performance and profitability. This is informed decision-making with the support from AI. Of course, you also improve the customer experience. Am I over the time? Yeah, I think I am a bit over the time.
Hello.
Hi.
Yes.
Okay. I will just scan through the slides very fast. Pricing optimization we talk about just now is another very important aspect of aviation operation, and AI definitely can play a part in this dynamic pricing optimization decisions. Similarly, using the three pillars, and cargo demand forecasting. This case study is talking about FedEx, how they use the AI to power the logistic intelligence. And this is actually a very interesting, case study, which I hope I could spend more time, but sorry, I know I rush a bit, because this is really talking about the, to create a symbiosis between, the AI and, the pilot. So the AI can actually collect all the, real-time information, sensors, weather forecasts, etc., to give the pilot a real-time informed decision-making to improve, pilots' decision-making accuracy and also reduce the pilot's workload. And this is another level that we talk about the enterprise, transformation from Emirates Airlines data decision lab. They actually carry the AI implementation to a different level, to set up an enterprise level kind of AI, decision lab, and then they actually initiated 47, AI projects in the past 2 years. Okay. And let's just quickly go to the challenges. Okay, and okay, let me see. Okay, maybe. Okay. How much time do I have?
It's already.
Okay, sorry.
Yeah.
Okay.
It's all right. we will share the slides
Yeah,
with the
slides. Yeah,
participants
yeah.
later after we finish all the webinar. And also, we have one question from Janine for you, Nelson. You can type the answer in the chat box to answer the question as well. Thank you so much for sharing your
Thank you.
expertise and practical examples for how the decision transformation in the